JEE Advanced 2021, Paper 1, Question 16. Physics, Fluid Mechanics, Accelerating Frame. Let us visualize the setup. An inclined plane makes an angle theta equal to 45 degrees with the horizontal. A cylindrical tube filled with water sits on this incline. The tube moves down the incline with a constant acceleration a. At the base of the tube, we have 2 points, point 1 on the downhill side and point 2 on the uphill side, separated by the tube diameter d. Gravity g acts vertically downward. The question defines beta as P1 minus P2 over rho GD. It asks which of these statements are correct. Option A, beta equals 0 when A equals G over root 2. Option B, beta is greater than 0 when A equals G over root 2. Option C, beta equals root 2 minus 1 over root 2 when A equals G over 2. Option D, beta equals 1 over root 2 when A equals G over 2. The key concept is analyzing this problem in the non-inertial frame of the tube. Since the tube accelerates down the incline with acceleration a, we introduce a pseudo-force of magnitude ma directed up the incline. The effective gravity has 2 components. Along the incline, it is g sin theta minus a, directed downhill. Perpendicular to the incline, it is g cos theta, directed into the surface. The pressure difference at the base depends on the component along the incline, since points 1 and 2 are separated along this direction. Step 1. Deriving the expression for beta. Point 1 is lower on the incline, so it has higher hydrostatic pressure due to the effective gravity component along the incline. P1 minus P2 equals rho times the effective gravitational acceleration along the incline times d, that is rho times g sin theta minus a times d, dividing by rho gd, we get beta equals sin theta minus a over g. For theta equals 45 degrees, sin theta equals 1 over root 2. So beta equals 1 over root 2 minus a over g. Step 2. Checking option A. When a equals g over root 2, beta equals 1 over root 2 minus g over root 2 divided by g, which is 1 over root 2 minus 1 over root 2, equaling 0. So option A is correct, beta equals 0. This also means option B, which claims beta is greater than 0 for the same value of A, is incorrect. Step 3. Checking options C and D with a equals g over 2. Using our formula beta equals 1 minus a root 2 over g, we substitute a equals g over 2. Beta equals 1 minus root 2 over 2, which simplifies to 1 minus 1 over root 2, that is root 2 minus 1, all over root 2. This matches option C exactly, so option C is correct. Option D claims beta equals 1 over root 2, which is approximately 0.707, but our calculated value is approximately 0.293. So option D is incorrect. Let me now show the general derivation. The 2 points at the base are separated by diameter d in the horizontal direction. Along the incline, their separation is d over cos theta. The effective gravitational acceleration along the incline is g sin theta minus a. The pressure difference is rho times g sin theta minus a times d over cos theta. Dividing by rho gd, we get beta equals tan theta minus a over g cos theta. For theta equals 45 degrees, this simplifies to beta equals 1 minus a root 2 over g. When a equals g over root 2, beta equals 0, confirming option A. The correct answer is options A and C. When the acceleration equals g over root 2, beta is 0, meaning no pressure difference between the 2 base points. When the acceleration equals g over 2, beta equals root 2 minus 1 over root 2. The key formula is beta equals 1 minus a root 2 over g for theta equals 45 degrees. Exam tips for JEE Advanced Fluid Mechanics. Tip 1. For accelerating fluid problems, always switch to the non-inertial frame of the container. Tip 2. The pseudo-force is ma directed opposite to the acceleration. Tip 3. Decompose the effective gravity into components along and perpendicular to the relevant surfaces. Tip 4. The pressure variation is rho times the effective gravity component times the height or distance along that direction. Remember these formulas: effective gravity equals g minus I as vectors and beta equals tan theta minus a over g cos theta. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.